Okay, in this video we're going to look at hypothesis testing, and it's a bit of a crash course on this. Okay, you've got three things in A-level Mathematics that you can test. You can test the normal, and when you're testing a normal, you're testing the mean. The first thing I want to do when I'm testing a mean for a normal is I write down how my distribution is distributed. So it's distributed with a normal distribution, with a mean mu, and a variance sigma squared. But also, that means x bar is distributed with normal, same mean, mu, but the variance is now sigma squared over n, and you will be given this n in the question, so maybe a sample of 30 people are taken, or whatever it happens to be, as we'll see in the question. Now for the normal distribution, your initial setup then, what you must do is say what your 80 is, and your 80 is just that your mu is the standard, whatever it was, up here. And then your H1, you've got three versions of H1 you could have. They could just say that the mean has changed. So they think that the mean has changed, in which case mu is not equal to whatever it was. Or they could think that there is just a negative correlation. Or sorry, the mean has decreased, I should say, which means the mu is less than whatever it was. Or they might think it has increased, in which case it is greater than whatever it was. And in this case, it would be a one-tailed test. So the first one was a two-tailed test, the second one was a one-tailed test. Okay, we're going to whiz through these and then go on with a couple of examples. So for binomial, testing, what you're doing for binomial is testing the proportion p. So I should have said here that your binomial, I would set it out, distributed with binomial, n is your number of trials, and p is your probability of success. So for the binomial, your H0 is always that your probability is equal to something, or your proportion is equal to something. And then your H1, the two-tailed test one, they maybe just think it has changed. They maybe think it has improved or increased. They maybe think it has got worse or decreased. And those last two are one-tailed test. And then the one, the product moment correlation coefficient, this is where you're testing for a correlation. Now it's a little bit different. The standard, the initial setup is that H0 is always that the rho is equal to 0, and rho equals 0 means there is no correlation. And then you want to test for the presence of some sort of correlation. So somebody maybe just has an idea, I think these two variables are related. So that means it's not going to be, rho's not going to be equal to 0, but maybe they're more precise and I think, okay, I think there's a negative correlation. So that means as one increases, the other one decreases. And then maybe somebody thinks there's a positive correlation. So maybe the more you study, the better your exams get. And in that case, they're going to be a one-tailed test. So the first one would be a two-tailed, last one would be a one-tailed. If it's a two-tailed, so say you're testing at 5%, if it's a one-tailed, maybe that 5% is just going to be up here. But if it's a 5% and it's a two-tailed, then you have to split your 5% in half so that it's at either end. That's really the only thing you've got to worry about for the different tails. So one-tailed, it's going to be at just one end, the whole 5%. But if it's a two-tailed at 5%, then it's split evenly on both sides. For all three, state the number of tails and also the level of significance. These potentially are very easy marks that you will get. Okay, we're going to look at a normal one, and then a binomial one, and then a product moment correlation coefficient one, and see and do both methods, for certainly for the normal and for the binomial. I have a preferred method, I have to say, to do these. But anyway, okay, right. Scores in an intelligence test are known to be normally distributed with a mean of 100 and a standard deviation of 15. First thing I'm going to do before I read on is write that down. So a mean of 100 and a standard deviation of 15, so that's 15 squared. Lindsay wishes to test her theory. Sorry, bear with me. Lindsay wishes to test her theory that drinking coffee before the test affects your score. She selects a random sample of 80 adults, so this is your N, and gives each a cup of coffee before they take a test. So that means X bar is distributed, and then it's going to be 100 and 15 squared over N. Oops, my N was equal to 80. So this thing here is really what we're going to worry about. This we don't really need to think about anymore, but it's the thing in the circle is what where everything is going to be considered going forward. Following the test, Lindsay calculates the mean score of the sample to be 104. Test Lindsay's theory using a 5% significance level. So Lindsay has this idea that drinking coffee before the test affects your score. Okay, so she said she thinks it affects your score. She doesn't say she thinks it gets better or worse. She just thinks it changes the score somehow. So this is actually going to be a two-tail test. So your 8-0, and you might get easy marks for this, is that your mu is equal to your initial mu, which was 100. And my H1 then is that it has changed, so mu is not equal to 100. And this was, that's going to be a two-tail test at 5% level. Okay, and we'll see when we go through the mark scheme, you could well be getting easy marks for this. So let's just do a wee diagram. And 5% is split evenly. And what we're going to find is we're going to test our value, and we're going to find, is it in here? Is it in here? Or is it in here? So I write this on, and then I decide where it is. And if it's in 1 or 2 or 3, then what we do is we reject H0. And if it's in 2, we don't reject H0. Basically, we have to write that up a special way. Okay, there's two ways of doing a question like this. Now, the first thing is I would mark on where my mean is. I'll get rid of that 2 for a second here. I would mark on where my mean is going to be. So my mean would be here. My mean would be here. It would be 100. So we have got 104. So 104 is going to be over on this side. So I only need to test this one end. So if you understand where 104 is relative to 100, and we need to test one end. So I need to see then basically it's not going to be in here. So it's either going to be in here or in here. So it's going to be in one of those two places. That's where my 104 is going to be. So we need to figure out how far along it is. So I want to find the probability that X bar is greater than or equal to 104. That's what I'm looking for. Okay. So I'm going to do that with my normal CD on my lovely new Classwiz calculator. So I'm going to the normal CD function, and when I go there, I'm presented with a few wee things for me to fill in. So I've got lower, upper, then sigma, and then mu. And then I just fill this in. So my lower value is a 104 because I'm greater than it. And technically, my upper value is infinity because this graph goes out to infinity. But we can't do infinity. The best we can do, just do 9 times 10 to the power of 99. You could even just put in as big a number as it will allow you to put in, and that will do the same job. But because my calculator allows me to do this, and my sigma, okay, now this is where the sigma, this thing here would have been sigma squared. So the sigma is equal to the square root of 15 squared is just 15 over the square root of 80. Now, depending on the calculator, some of them will, what have I just said, 15 over square root of 80. So it's going to be 15 divided by the square root of 80 is what I put in. And my mu is my original mu, which was 100. So let's fire that in. So 15 divided by the square root of 80. And then when I do that in my calculator, by the way, it changes my sigma to be 1.677 and my mu is 100. And put that in, and then what I get is a probability that X bar is greater than or equal to 104. What it's given me in my calculator, the 3 sig figs, is it's 8.536 times 10 to the minus 3, so 0.00854, the 3 sig figs. Okay, right, so that's a pretty small wee percentage. So if you look at that, it was only 0.8% basically. So it is going to be, and this is where I just score these out, it's going to appear in here. So where this wee arrow is, that's where my 104 is going to be. Okay, so I am just going to say in critical region, I just say therefore, and a nice way to say it is sufficient evidence at 5% level to reject H0 in favor of H1, and also relate it back to whatever the question is. So that was about coffee and intelligence test. So just say i.e. evidence that coffee changes performance in intelligence test. Okay, and that should get you the marks. All right, now let's just look quickly at the mark scheme and we'll see what they have done. Oh, where on earth is it? They've done a slightly different thing. Don't be panicking about this. You can use your Classwiz. This is absolutely fine. But you can see they have been able to say the same thing. But just to show you why I'm really showing you this, all of these marks, you get a mark for doing your H1, you get a mark for doing your H0, a mark for doing your H1, and I think probably you would have to say it's a two-tailed test. And then as well, there you've got a mark for setting that out. Great, that's nice. And then, so the next bit then to do all the working out there, that's 1, 2, 3, 4, 5 marks. And the last 2 marks are only for this bit up here. So basically you figuring this out. This is a bit people don't like. So if you don't get that, you've only lost 2 marks. You've got everything else really. So it's a really good way of doing it. Okay, right, we're going to look at another way we could have done that. And you do need to know both of these ways because sometimes it will ask you to find the critical values, the critical region, or whatever it happens to be. So we're going to do the same thing again. It was X bar was distributed N and then 115 squared over 80. I'm just going to write that all down again. Okay, and we know our test value was, it was H0 was mu is equal to 100. H1 was mu is not equal to 100. So again, you'd just say it's a two-tailed test at 5% level. We're whizzing through this. And I would mark on where the 100 is, the mean, and then because I really need to find this upper tail. So I don't need to bother finding the lower tail. I'll just find the upper tail. So I want to find what this CR, what this critical value is. So we're just going to say find CR, the critical value. And then I can say I'm going to actually use my inverse normal mode. So I'm going to use inverse normal. Okay, and if you imagine if that was my CR, that's 0.025. So if we just do that, 1 minus, the other side of that, 1 minus 0.025 would be, and if we do that as a decimal, it's going to be 0.975. So why we need that when we go into our inverse normal, the inverse normal only does the left to the left of your value. So it gives you, it only works with this area here. So that is 0.975 for my area. And 0.975, and then my sigma. Remember, my sigma was the 15 divided by the square root of 80, and my mu was 100. So we'll just put those in, 0.975, and then my sigma was 15 divided by the square root of 80, and then 100 for my mu. And when we did that, I got that therefore my CR was equal to 103.29. I'll go to two decimal places there, 0.29 to 2 decimal places. So you can see then, if you do it that way, you could say then the critical region, because they could ask you this, the critical region is X bar to be greater than 103.29. So basically, if your test value is anything greater than 103.29, then you reject your 80. So here, we'll just say, so 104, that was our test value, is greater than 103.29, therefore reject 80 in favour of H1, and you would put in that wee spiel again about it being the intelligence has improved, or whatever, has changed, sorry, I should say, with drinking coffee. Okay, that's your normal, the two ways of doing the normal. We're going to look now at our binomial one, and this is testing a proportion. So it says here, a drug to treat hay fever is claimed to be effective on 80% of sufferers. A doctor specializing in allergies suspects that the effectiveness of the drug has been overstated. He takes a random sample of 20 of his patients whom he has treated with the drug, and he finds the drug was effective on 12 of them. Okay, right. First of all, let's say how this is distributed. So we're looking at this. X is distributed binomial. My N is 20, and my P is claimed to be 80%, so 0.8. So in this one, let's say what our 80 is. Our 80 is that it's just equal to 0.8, so it's the default, but he suspects it's been the effectiveness is overstated, so he doesn't think it is as successful as 80%, so he suspects it is this, which means it's going to be a one-tail test. And in this question then, it's going to be this. So I'm ignoring, by the way, this part of the question. I couldn't care less about it. Right, that is your assumptions for binomial. You just put those in. Your assumptions for binomial are just that it is either success, two possible outcomes, success or fail, a finite number of trials, and the results are independent. They are independent events. So you need to learn those. But we're not looking at that at the minute. We're just looking at this. So it's a 5% level. So 5% level, that's all we're doing. Okay, right. Now, what we need to do, I always like to draw a diagram. Now, I know this is not technically it is not a normal distribution, but I like to draw it. It just keeps it right for me. And it's on the lower end, and I want this to be 5%. So I want to find the chances of me being less than my value being 5% or less. Okay, so it says 12 of them. So I want to find the probability that X is less than or equal to 12. That's really what I'm looking for. So we're going to go into our binomial CD. And we're going to have a wee look at our binomial CD. And go into binomial CD, I just like to go into variable. And then your X is 12. Your N is 20, and your P, your probability of success, is 0.8. Fire those in and see what we get. So 12, 20, 0.8. Press equals, and I have worked out that probably the X is less than or equal to 12, then is equal to 0.0321 to 3 sig figs. Okay, now let's see where that is. And again, you've got the bulk of your marks. It could be in here, or it could be in here. So it was 3.21%, and 3.21% is going to be in 1. So again, there is evidence to reject 80 in favour of H1. So again, let's just write that up. I would just say, in critical region, so evidence at 5% level to reject H0 in favour of H1, and that just means i.e., and then relate it back to the real world situation, evidence, and we'll just say to back up the doctor's claim. Okay, right. Now, we may also have to do it where we find the critical values, which I am not a big fan of, especially for the binomial. So if I can do it this way, I will do it this way, and this question allowed me to do this. If not, it may ask me to find the critical region, so we have to look at it a slightly different way. Okay, so let's set this out again. So the other method, x is distributed binomial. It was 20 and 0.8. My H0 was that p was equal to 0.8. My H1 then was that p was less than 0.8. And we had to see the value, the lowest value that goes into that. So I want to find basically the first value that we come to here, first value that we come to here, such that less than that value is less than 5%. So we've got to find, we're going to do this by finding the critical value. I'll just call that CR. So we want to find CR such that the probability that x is less than CR is less than 0.05. So the first value that comes into there. So you've just got to test it out. So I'm just going to do this on my calculator. I'm using my binomial CD, and I'm just going to try a few of these. So binomial CD, first of all, and there is another way of doing it, which I don't like, but binomial CD, and you're just putting in x, n, and p. Now your n is going to be 20, and p is 0.8 for all of them, and you're just going to change this and try these out. So let's just put in, I'll put in 16 first of all, and when I put in 16, what I got was probability x is less than or equal to 16 is equal to 0.588, so 58.8%, okay, way too big. So I'll try something else. I'll go into that again, I'll change, so that hasn't worked. So I'm going to try, we'll go down to x is less than or equal to 14, and x is less than 14, it was 0.196, so again that's not right. That's 19%, go down to 13, and probability x is less than or equal to 13, and that is equal to 0.0867, so not in the critical region, but it is pretty good. X is less than or equal to 12, and put the 12 in, and you can see probability x is less than or equal to 12 is 0.0321. So that actually was our value we used, and our value was the first value that fell into the critical region. So you could say, if you're asked for it, the critical region is x is less than or equal to 12. So anything 12 or below is going to be in our critical region, and that is it. So just say, so our value is in critical region, hence reject H0 in favour of H1. Okay, and then you do the other wee spiel again about relating it to the real world as we had done earlier on. Okay, again, how many marks do you get here for this? Again, we ignored that a bit, didn't we? Just to show you, look at the marks, the easy marks you're getting here. It is a 1, 2, 3, 4, 5, 6, 7, 8 mark question. You get a mark for saying you're H0, a mark for saying you're H1, and also it's a one-tailed, a mark for setting up x is distributed binomial 0.8. And we have found if you've got your x 12 is less than or equal to that, there's another mark, and we found our values and so on, so there's another couple of marks. So it's only the last two marks If you don't understand that, if you don't get it, you're only losing those 2 marks. So the rest of it is all pretty straightforward for you to do, whatever way you're doing. It's definitely doable with the Classwiz calculator. Makes life an awful lot easier. Okay, right, our last type of one, and there's a lot more variations of this. This video does not cover everything, unfortunately, but covers, hopefully, the type of questions you're going to get. Who knows? So it says a researcher is testing whether the product moment correlation coefficient of a bivariant, that just means 2 variables like height and weight or whatever, bivariant population is positive for a random sample of size 12. So that's my n is equal to 12. He calculates that r is equal to 0.516 and decides to use a 5% level of significance. Write down the critical value for a one-tailed hypothesis test. Now, there's only 1 mark for this question. I would be doing a lot more, but you'll see, I'll set this out so it can work for everything. So here, if you're doing this, I would just set everything out. I don't know where we're going to get our marks for or how we want to set this out, but 80 is for this. As we said at the start, rho is always equal to 0, and he believes for a random sample he calculates r is equal to that. So it's positive. The research is testing whether product moment correlation coefficient of a bivariant population is positive. So he's testing whether it is, greater than 0. That's really what he's testing from that first sentence. Okay, we need to then look at our tables and find this. So it is 5% level, and I know it is not a normal distribution, but I just like to put that in. This keeps me right, and I'm going to find, is it better than my value? So what our tables are going to give you basically are the critical value. So we're going to get this critical value from the table, because we know his value is 0.516, and then we can use that. So if it's here, we wouldn't reject 80, and if it's here, we would reject 80. So we just need to find the test value. So the value, write down the critical value. So critical value, we're going to get that now. Let me just write down critical value. Okay, we were at 5%, and it was n was 12. So where do we get this? From our table formula booklets. The only way to do it is on our formula booklets. Where on earth are we? Right, 5% is here, and 12 is here, and it is just where those 2 things meet. And you can see that is where they're going to meet. If I just went down to there, that is where they're going to meet, and it is 0.4973. 0.4973 is my value. So critical value is equal to 0.4973. Part 2 then says, based on this value, what conclusion can the researcher do or draw? So I'm going to mark in my critical value then, which is 0.4973. And then our value was 0.51. So up here, it is 0.516. So just mark it on. It's going to be there, 0.516. So we'll just say 0.516 is greater than the critical value. Therefore, evidence to reject 80 in favour of H1, i.e. The researcher prediction was correct. Okay, and let's just look at the mark scheme. Not very many marks awarded for this question at all. But it's a bit of a strange one, really. You can see all they've done is 0.4, found the value, and then they've just said, since our value, the value that we had been given was greater than that, there is sufficient evidence of a positive correlation. That's what it was, positive correlation. I've forgotten what he'd said, at a 5% level, and that's it. Okay, folks, hopefully that has eased a few concerns about our hypothesis testing, and really what I want you to take away from this is how many marks you can get without understanding, without getting the very last bit. Obviously, we want to get that understanding, but you can get a lot of marks just by writing down your H0 and your H1 and the initial setup and so on, the level maybe even just. And you can see again in this one up here, a lot of marks can be found by saying your H0, your H1, and your setups and the number of tails, all of that stuff. You can still get loads of marks. All right.